Step 1. Draw a solid signboard by creating a single vertical line. Then set the flow speed to 20 meters per second and press run. Next, move to step 2 to record the results. Press stop once the calculation has converged. Then click the coffee cup icon, followed by the Box Probe button. Draw a rectangular box around the signboard to measure the pressure on all 4 sides of the plate. In the probe window, the measured pressure values will be displayed. Save this window so the data can be analyzed later. Also remember to save this case. For the second case, which is the signboard with holes, start by resetting the case, which will return the single straight line. Then delete sections of the line to create the holes and press run again. Once the calculation converges, repeat step 2 and check the pressure graph. For the third case, draw a tilted signboard by creating a line at a 30-degree angle, then press run. At this point, you'll have the results for all 3 configurations. Now open the graphs that were saved earlier for the 3 cases. The box probe draws a rectangle around your object and measures the pressure at every point along its 4 edges. Starting from the bottom left corner, it traces the perimeter clockwise, bottom, right side, top, then left side, and records the pressure value at each step. The graph shows this as a single continuous line, where the horizontal axis is how far you've traveled around the box, and the vertical axis is the pressure difference from the free stream. You can see 4 distinct segments separated by dashed lines, one for each face of the box. To calculate the forces, it integrates, or sums up, the pressure along each face. The left face collects the incoming high-pressure wind pushing rightward, while the right face sees the low-pressure wake pulling leftward. The difference between these two gives Fx, the horizontal drag force. Similarly, the bottom face pushing upward minus the top face pushing downward gives Fy, the vertical lift force. The key insight is that this box does not touch the object at all. It captures the net effect of everything happening inside: the front stagnation, the rear suction, the separated wake, all in one clean pressure integral around the boundary. Whatever force the fluid exerts on the object must cross this imaginary box, so integrating the pressure on the box gives the same answer as integrating directly on the object surface. The result shown is a raw 2-dimensional force per unit depth in newtons per meter. In the first case, the Fx value is 3,400. For the signboard with holes, the Fx value is 2,964. For the tilted signboard, the Fx value is 2,638. In conclusion, the tilted signboard experiences the lowest force in the x direction.